Hi, guys. Today I'm very excited to be discussing how to secure your APIs that are deployed using the API gateway. We are going to do a deep dive and we are going to discuss how to comprehensively implement security in your APIs. Now, no one can claim, especially on the internet, that the security guidelines they are providing that would provide 100% of protection. It is just because of the nature of this space. It's continuously evolving, and within the security realm, a chain is as strong as its weakest link. But I can confidently say that if you follow these principles and incorporate the best practices, the security infrastructure of your API would be as good as it gets. I have made a deliberate effort to not focus on just few aspects of API security. I have focused on all the aspects of the API security so that we can discuss applying security at all layers and implement comprehensive security for our API infrastructures. Getting to the main part of our discussion, we will first start off by going over the main design principles that we are basing our discussion and security implementation on. My discussion is obviously focused on Amazon API Gateway. The rest of the slides talk about implementing security in the context of Amazon API Gateway. But these principles you can actually take and apply to any API implementation. They are applicable across the board. These are design principles that apply to any API. First principle is protection of data in transit and at rest. This refers to encrypting data when in transit, and when you store it, encrypting data at that time as well. And that this part is called encryption in transit, protection at rest. Second point is a general security best practice that says that you implement the strong identity and access foundation, and also you incorporate centralized control over your IAM implementation. We'll talk about more on this. And obviously, the principle of least privilege access is also a very important part of implementing a strong identity and access foundation. Third point is we have to make a continuous effort to minimize our attack surface. So we have to give hackers less targets to hit on. When you are implementing an API, in most of the cases, you can just have one public endpoint, which is your API, and the rest of your system can be just private, isolated from the rest of the world. The next principle that we are going to discuss is the need to mitigate DDoS attacks. DDoS attacks are a fact of life, and whenever we are designing our system, whenever we are implementing security, this should definitely be something that we should add protection for and expect that this will happen sooner or later. After that, we will touch on how to incorporate inspection to further secure our API gateway. And this talks about how the pre-processing the requests, filtering them, and even this also refers to any transformation, any enrichments that we add. This also refers to that. After that, we will talk about the importance to have extensive and comprehensive logging, traceability, and auditability. This just applies to any part of the system that we implement, whether it's API, front end, back end, middleware, anywhere. This is just a general security principle that applies everywhere. Similarly, the last one is very important, which is that we need to apply security at all layers. And obviously, it applies to the API gateway architecture as well. A little bit details on the principle of protecting data in transit and at rest. Within the context of API Gateway enforces that all communication with it are encrypted. So it enforces encryption in transit for us. And whether you are invoking the API, it should be through HTTPS. And when you are making control plane operation calls, like as an admin, when you are creating an API or doing other CRUD operations, those calls obviously are encrypted as well because they are happening via the AWS API, which is very secure and encrypted. In terms of data at rest, since we are getting data in transit for free from API Gateway, but for data at rest, we have to implement it ourselves. But it's not a big implementation, but it's a quick implementation. It's mainly just configurable. First, it's important to understand that API Gateway doesn't store any persistent data, so we don't need to worry about that. But any data which API Gateway is going to cache and store as a cache, API Gateway will store it in encrypted form. Obviously, it's an implementation level detail which is hidden from us. It is AWS that is taking care of this, but it's good to know. And the API definition, obviously, they are stored in memory. So we don't have to worry about encryption at rest for the API definition. But once again, this is an AWS implementation details. Also, for integration responses, caching can be configured to use encryption. Now, what we need to handle as far as encryption at rest is concerned, the encryption when we store the logs, since API Gateway doesn't store the logs, it just defers logging to a logging service like CloudWatch. So we just have to make sure in our implementation, this is an action item for us now, that the logs, the log groups, the CloudWatch log groups that we are using, they have encryption enabled. It's a configuration thing. You just click it and it gets enabled. Or obviously, if you are using IAC, then it would just an attribute to the log group directive. Similarly, you can also use Kinesis to ingest logs. And Kinesis obviously has also the option to make to enable encryption. Implementing a strong identity and access foundation involves multiple aspects. The first one obviously being using a well-known and secure identity provider. Within AWS, we usually use IAM, but we can delegate the identity provider to some other third-party provider. For example, Microsoft Active Directory. This is where this notion, the concept of centralized control comes into picture as well. So if you have users, those would be obviously belonging to some company, some organization. They would be using some sort of identity provider for identities. And one of the main best practices within the identity space is to use centralized identity providers. So we, in this scenario, let's suppose if the users are using Active Directory as is depicted in this diagram, we don't need to create separate identities for them in IAM. We can just integrate Active Directory with AWS. That is gonna get done via AWS SSO. And then AWS SSO is going to be using the Active Directory as the identity provider. And then you can implement policies within IAM and associate them with your Active Directory users and user groups. So when they log in, those policies get applied to them. So using this approach, you could just use Active Directory as your identity provider. You don't need to create separate IAM users. You can implement policies that would get applied to those users when they're gonna log into AWS. This is also called the process of federation. So when they would get federated, they would be able to use AWS services, including API Gateway in the context of our current discussion. Another important aspect, obviously, that I wanted to touch on is the principle of least privilege access. I'm assuming you already know about it, but that is something that needs to be mentioned whenever we are discussing identities. Now, what we just discussed covers the part where you have users who are managing your API Gateway instances, and they need to log into the AWS console or use any other interface to AWS like AWS CLI. So we covered the admin aspect to it. But what about the API invokers, the clients, the users who would be invoking your API, methods. For that, API Gateway provides us multiple options, and the first one is being able to integrate with Cognito. Cognito, being a native AWS service, has built-in integration with API Gateway. All we need to do is just configure and specify the pool that should be used, user for authorization, and we just create a Cognito authorizer and specify the pool that it should be using for authorization. In case you need to implement any custom logic for authorization, API Gateway integrates with Lambda authorizers. All it does is it invokes a Lambda function, and the authorization part is delegated to that Lambda, and that Lambda you could implement any custom logic for authorization. The third authorization approach is using IAM based authorizers, and actually it is recommended that if possible, if you could use the IAM based authorizers, then use these, because it uses the same service, which is IAM, for managing access, so you don't have to use some other service. And obviously you are using the same service which the rest of the AWS APIs use to authorize the API calls. The one possible caveat to this approach is that you would have to sign the requests in the way AWS expects them to, but it's actually in reality is not that much of a problem, because anything you're going to use, it's highly likely that it's going to have support or a module for signing requests using AWS format. There is another capability which the AWS API Gateway supports out of the box, and that is certificate-based authentication via mutual TLS. This actually is something that should be considered whenever we want to implement authentication and authorization in our API Gateway, because it provides actually better security, because it's mutual authentication. Not only is that the server authenticating, the client side also authenticates the server as well. So it is more secure. It's passwordless. There are no access codes or access keys being passed around. So it's more secure than the standard OAuth approach, and should definitely be considered in our API Gateway security design. When you talk about minimizing attack surface, I touched on this earlier. It is mainly what you want to do is limit your exposure and give the hacker and the attacker less targets to hit on. So inherently with the API Gateway, we get a single point of entry into our system, but we have to make sure that anything else that sits behind the API Gateway, like our compute logic, the Lambda servers, DynamoDB, if you have an RDS DB instance, all of those are public, isolated in a VPC in a private subnet. So we need to make sure that that is happening. So this way, if you implement this architecture, then everything else is private. Only you are exposing your API Gateway to the public endpoint, and then everything else is basically private within a VPC in the private subnet. Now, there is another additional security that you can incorporate here, and that is the possibility of using a private endpoint for your API Gateway. So your API Gateway would not be accessible publicly. And if you just want to use the API within your VPC or within a VPC that you have established through like one of your transit VPCs, then you should definitely consider using a private endpoint, because you don't need to expose your API Gateway publicly, and you can just get what you want, get the functionality that you want using the private endpoint. And that is a good example of minimizing your attack surface, because in this case, the API Gateway endpoint didn't have to be public because you were accessing it from within only a specific VPC, and you just made it a private endpoint which is available to the VPC. Also, another implementation of minimizing the attack surface is using resource policies on your API gateway. Resource policies are required for private endpoints but are optional for public endpoint. For a public endpoint, you can have a resource policy and you can only allow access to specific AWS accounts or specific IP address ranges. So this is also a good implementation of minimizing your attacks surface, because you know that it would only be accessed by a specific account or specific set of IPs. You are only opening it up to those sources and not to the entire public. So here in this diagram, we're depicting that we have a resource policy that is only allowing source IP this, and we have an external client with the source IP this, and it is able to access the API gateway. Any other source would not be allowed to access the APIs. Let's talk about the very important topic of mitigating DDoS attacks. One approach, we have multiple options here, and usually you would use a combination of these options. So first available option is to use rate limiting, which is supported out of the box by the API gateway. There is something called usage plans that if you incorporate that, then each caller with the specific usage plan would be restricted to whatever rate you have allowed them to. The other implementation of rate limiting is done by AWS for us. There is some account level rate throttling which AWS implements, and the only way to change it is to make a service request to AWS support to increase it. We also use CloudFront for DDoS mitigation as well. CloudFront, as you know, is Amazon CDN service, and it provides edge locations across the globe. It caches data on those edges and serves user requests from those edges if you have configured caching correctly. We can leverage this architecture for DDoS protection as well, because if users are being served from a specific edge location, even if they initiate a DDoS attack, the requests are not coming to our infrastructure. It is just being searched from the edge location. As far as integrating CloudFront to API gateway is concerned, it is very easy. It's just a configuration option. You just select edge-based endpoint and Amazon is going to use CloudFront. It would not be visible to you, but the content would be served from one of Amazon's CloudFront distributions. You can also use a custom CloudFront distribution with an API gateway. Obviously, that would require provisioning a CloudFront distribution and managing it. Since we are talking about DDoS protection, we should also mention about Shield service, which is a service provided by AWS for DDoS protection. I'm not gonna go into too many details about this, but it is a service that is dedicated for DDoS protection. Shield has two variants. One is the Shield standard, which we all get for free, and then there is an advanced one which provides advanced DDoS protection for anyone who subscribes to it. With regards to implementing inspection, an implementation of inspection is request validation. This is something, once again, which is provided out of the box by the API gateway. You could enter rules to validate the request. For example, if you expect a certain format of a message, if it needs to comply to a certain schema, you could implement request validation. And before the request would actually hit your API, it would be checked if it contains that schema. If not, then the request would be denied and an error would be returned to the user. Similarly, you can also implement request transformation. You can do enrichment and filtering and restructuring of data before it reaches your backend. And third one, which is very important, I think it's a strong statement. So I mean, I'm gonna say, I'm not gonna say no, but I'm gonna say most production deployments should have a WAF integration, whether it's an API gateway, whether it's a load balancer, that any publicly facing service should have WAF integration on it, unless there is like a very strong reason not to have one. So this does filtering. So it looks at the request and then matches the request against certain rules, against common known exploits. So for example, if someone is trying to do SQL injection or any other well-known exploit, then it basically denies those requests. Also, you can use WAF for DDoS protection as well, because using WAF you can also add rate limiting rules. So this is just a visualization of what we just covered. Very important, obviously I mentioned earlier, very important in any system, whether it's backend, it's API, front end, is the ability to have auditability, full end-to-end traceability, and comprehensive logging. So for this, obviously the AWS family of services are very extensive and they cover most use cases. So for example, for logging, AWS, the API gateway publishes logs to CloudWatch. It also publishes metrics to CloudWatch metrics. And we have CloudWatch alarms to set up alarms in case anything that we are monitoring, any thresholds, they are breached. And we have AWS X-Ray as well, which provides end-to-end traceability of request. And obviously all these services are also used along with other AWS services as well, not just with the API gateway. And of course, for auditability, we have CloudTrail, which is used with the rest of the AWS services as well for auditing purposes. Automating security best practices, it's just it's very important. And here are some examples that I documented from the source I use for this presentation. But this basically applies to everything, security as well as any other thing. But security, it's obviously very important, is incorporating automation wherever possible. Here are some examples that I've quoted. I will share the link to the slides. You can go over them if you are interested. Once again, not just limited to the API gateway, but it basically applies across the board to any architecture design, and that is that we need to apply security at all layers. We need to use a layer-based approach to security, and as we all know, a chain is as strong as its weakest link, and this applies so much to security. I mean, we can have the best security everywhere, but only one part that is exposed, the hackers could get in. So that's why it's very important to take a layer-based approach to security and apply security in all aspects of the system. This is a very good and comprehensive example of security being applied to API implemented using API gateway and other AWS services like Lambda, DynamoDB, S3, and Aurora. So we'll just quickly go over this. So here AWS Shield is providing DDoS protection. So is Amazon CloudFront, what we discussed earlier in the slides. We have also implemented DDoS protection on AWS or on WAF, assuming we have some rate limiting rules here. And now this is pointing to minimizing your attack surface approach. Here we have resource policies that are only allowing access to specific IPs. This is the introspection principle in practice. We have some input validations that are done before the request reaches our Lambda. We are validating the input and they should be complying with the expected schema. Authentication and authorization is being done by Cognito. When Lambda executes, Lambda's role only has the least privilege access required to perform its task. It is doing something with DynamoDB. So in the case, let's suppose you are querying some record, let's suppose you are looking up orders. So in this case, the role for the Lambda function is only going to have get or read access, whatever the IAM action name is, on the specific DynamoDB table that is being queried. I had recently did a video series on building serverless applications using CDK. We did implement this principle in the Lambda role. Basically, the role was only given access to the one table that the function was querying. So here we are seeing the principle of least privilege access in action. I'm going to skip this slide because it mainly just talks about what I just covered. And this is it. I hope you liked the content. Like I said, I'm very confident that if you follow these principles, you would be in very good shape as far as your API and the rest of your system's security is concerned, because towards the end we also covered like end-to-end security implementation. Please subscribe to the channel if you haven't done so. I really appreciate that. And there would be another video which I'll be doing. It would be like a second part to this video, where we are going to implement most of these concepts that we discuss. So make sure you watch that video as well. Thank you once again, and until the next video, bye.